This video will illustrate the structure and components of prokaryotic flagellum. One key difference between eukaryotic and prokaryotic flagella is its mode of movement. Eukaryotes move in a bending and whipping motion, which is ATP driven, while prokaryotic flagella run in a rotary movement, which is run by the proton motive force. The flagella consists of three main structures: the basal body, hook, and filament. The basal body is anchored in the cell membrane and transits the peptidoglycan layer. The basal body serves as a structural anchor, polymerization platform, secretion conduit for the hook and filament proteins, and contains the rotor and stator for torque generation. 32 genes for basal body are concentrated in the 27 kilobase operon. Initiation factor sigma A binds the RNA polymerase to the promoter to begin transcription and translations of these proteins. Assembly of basal body begins with type 3 secretion apparatus, which is composed of protein fly O, P, Q, R, A, and B. Flagella secretion requires the proton motive force, so it is believed that these proteins form a proton channel to create the electrochemical gradient within the membrane. The base of the basal body is a membrane-anchored ring polymerized from multiple subunits of fly F. Beneath these subunits sits fly G, that polymerizes into the rod. Below fly G are two rings made up of fly M and fly N that interact with the chemotaxis system and controls the direction of flagellar rotation. There are three different types of rings that facilitates the rotary movement. Ring L, P, and MS are embedded in the outer, peptidoglycan, and inner membrane respectively. These rings make up the rotor component. The proteins MOT A and MOT B surrounds the rotor and makes up the stator. The fixed stator interacts with the rotor and can start and halt flagellar rotation. Charged residues in the C-terminus interact with the MOT A complex to generate the torque for rotation and is then imparted through fly F to the flagellar rod. The rod serves as the axle to transmit basal body rotation to the hood and filament. The rod is assembled from four proteins, flag B, C, F, and G. The completion of the basal body acts as a channel for polymerization for the hook and filament. The hook is a curved hollow cylinder situated between the basal body and the filament that acts as a universal joint and allows for the change in angle of rotation. Protein flag E constitutes the primary structural subunit of the hook and is secreted by the basal body through the rod and polymerizes underneath the cap protein flag D. Protein flag K regulates the length of polymerization of the hook. Without this protein, polymerization goes unregulated and results in the extended structure of flag E and an irregular hook length. The length of flag K domain is proportional to the length of the hook, and hook polymerization is terminated when flag KC terminus activates autoproteolysis of the membrane protein flag B by direct contact. Thus, the length of flag K primary sequence controls the duration of flag E secretion at the individual basal bodies. Once the hook is assembled, sigma D is activated and expresses another set of genes dedicated to filament assembly. The filament is a helical propeller composed of repeating protein monomers called flagellin. Flagellin is polymerized together to form a 20 nanometer wide filament. There are two homologs of flagellin. HAG is essential for flagellar assembly and encodes the flagellin monomer protein H antigen. HAG proteins are secreted in its unfolded state through the hollow flagellar rod and hook by the type 3 secretion system apparatus within the basal body. Intracellular chaperones fly S facilitates the secretion by binding to and delivering HAG to the TS3 apparatus. Once HAG monomer emerges from the secretion conduit, it is then encountered by extracellular chaperone fly D that catalyzes flagellin folding and ushers flagellin assembly at the tip. Chaperone fly D also serves as the filament cap, and if absent, would leak and result in accumulation of flagellin in the extracellular medium. Fly D also polymerizes two structural transition proteins.
Created using Powtoon.